What do you think is the content of this thin container here? Cookies, sewing kit, art materials, or none? Would you believe me if I say that this can contain all of those? Well, not unless this is a quantum system that can assume all of those. This is according to the principle of quantum superposition. Quantum superposition states that a quantum system does not have a definite state before it is observed, only sets of probabilities of being in a specific state. Does quantum superposition sound familiar? Well, maybe because you've heard of this, the Schrödinger's cat thought experiment.
But first, let us take some history.
In the early development of quantum mechanics, physicists are baffled with the idea that quantum systems can exist as both a wave and a particle.
They are completely baffled.
But our friendly physicist Erwin Schrödinger devised an equation that can predict the behavior of a particle over time with the consideration of its wave-particle nature. However, there seems to be a problem with this equation, but this is quickly solved by another friendly physicist, Max Born. Max Born suggested to square the equation to yield real results. And that the equation does not predict the behavior of the particle over time but the probability to find the particle in distant locations. So, the Schrödinger cat thought experiment involves a cat enclosed in a box with a vial of poison which is triggered by the decay of an atom. This atom has a 50-50% chance of decaying. If the atom has decayed, then the cat is dead. If not, then it is alive. This imaginary setup has made the atom and the cat entangled. Entangled what? In the quantum world, if we say that a pair of systems is entangled, then it means that they affect each other in a sense. If we know about the state of one, then we can figure out the state of the other. So, the cat and the atom are entangled, and Schrödinger thought, is the cat dead or alive? With the equation Schrödinger devised and the interpretation of Max Born, it was implied that the cat is neither dead nor alive, but it is in a superposition of being dead and alive. Is that weird, having a cat in a superposition of being dead and alive? Well, don't worry, we are not to see any cat walking around dead and alive anytime soon.
Why is that?
This is because of the wave function collapse under the Copenhagen interpretation and the decoherence under the many worlds interpretation. In the wave function collapse, when a quantum system that is in a superposition was observed or measured, the wave function collapses into one single probability that exhibits one specific state, while the decoherence idea states that the wave function never collapses, but instead, the quantum system loses its ability to act independently or be in a superposition, as it is affected by its interaction with the outside world, forcing it to assume a single classical state. So we are not to see any cat both dead and alive. Going back to the question at the start of this video, the content of this are cookies. Thanks for watching!